All right, students, good afternoon. So today we'll be doing the numericals of second part of calorimetry chapter that was yet to be done. So we'll be starting. So starting with question number 1. So question number 1 is what? 10 gram of ice at 0 degrees Celsius absorbs 5,460 joule of heat energy to melt and change to water at 50 degrees Celsius. Now you need to calculate the specific latent heat of fusion of ice. Okay, so here two things are given. First of all, you have to see that the 10 gram of ice at 0 degree. So how you are going to calculate this? First of all, you have ice at 0 degrees Celsius. Okay, so this is going to convert to water at 0 degrees Celsius. Okay, and then this is going to convert to water at 50 degrees Celsius. So at each stage you have to calculate the energy conversion and then you have to equate, and then you can easily calculate the specific latent heat of fusion. Okay, so how you are going to write? You will write that let the specific latent heat of fusion, specific latent heat of fusion of ice, of course, be, let that be L. So what is the unit? The unit is joule per gram, or L you can write G minus 1. Okay, and then what you will be writing, therefore amount of energy, before amount we'll write down the mass. Okay, so what is the mass of ice? The mass of ice to us has been given as M is equal to 10 gram. So what you will be writing, amount of heat energy required for water at 0 degree, sorry, ice at 0 degrees Celsius to convert to, for ice at 0 degrees Celsius to convert to water at 0 degrees Celsius is equal to what? This is mass into latent heat. So what is the mass that we have? Mass that we have is 10. We need not convert, because here you can see the specific heat is also given in grams. So it's very fine if you are leaving it like this. And the latent heat is something that you don't know. Okay, and the next thing that you will be write is amount of heat energy required. Okay, so write down amount of heat energy required for conversion of 10 gram of water at 0 degrees Celsius to, how much is the temperature? 50 degrees Celsius. Will be equal to, found the formula is M into C into delta T. So here what is M? M here to us is given as 10. What is the specific heat of water? It's given as 4200 joule per kg per Kelvin. So what are you going to write here? See children, in the question you have been given as 4200. So what are you going to do? See, the two things which are there is either you can convert, okay, this specific heat capacity which is there into gram, or else what you can do, you can convert the mass which is there into kg. Okay, so here what we are going to do, we are going to convert this into, it's given as joule per kg per Kelvin. So we'll just write this as, let this be at, we'll just take this as mass as 0.1. So it will be 0.01 into 4200, that is joule per kg per Kelvin, into what is the temperature to me has been given as 50. Okay, so when you are going to calculate this, you are going to get this as 0.5 into 4200, which is equal to 2100 joule. Okay, then what you are going to write, that what will be the total energy absorbed to you has been given as 5460 joule. All right. So next what you are going to do, therefore, total energy is equal to, so you can write this as E1 and this as E2, so that you don't have to write the entire things again, is equal to E1 plus E2. Okay, so this implies the total energy, which is 5460. This is equal to how much? See, here you can see we are keeping everything. The question that may arise to your mind is that, ma'am, you have taken here 10 in grams, and latent heat you have taken, that also you have taken in joule per gram, and here you have taken it in kg. Okay, and here you also you have taken in kg. So one place you have taken grams, another place you have taken kg. See children, this is not going to make a difference. Why? Because at the end of the day, gram and gram is going to get cancelled, and you are going to get only j. So energy whichever is there, they are there in joules. So even if you are calculating one in grams and another in kg, that is not going to make any difference. Okay, so it's not. Why? Because at the end of the day, this is also joule, and at the end of the day, this term is also going to be joule. So joule and joule can be added. So whatever cancellation was there, here gram got cancelled with gram, and here kg got cancelled with kg. So it's completely fine. Okay, so here you will be writing m into L plus 2100. So this further implies what? That ml will be equal to how much? See, mass is something, sorry, 10L is what you will be writing, not ml, because we have already substituted that. So write down 10 into L is equal to this much. So 10L is equal to 5460 minus 2100. So which in turn is equal to how much? This is 0, this is 6, 3 and 3. So this implies L, what we are getting is 336, and the unit is joule per gram, because that is what we had taken initially. That let the unit be this. So even if you are taking grams once and kg once, that is not going to make a difference, children, because at the end of the day, both are joule. Okay, so you are not expected to get confused. Now, the next question will be moving on to question number 2. So in question number 2, what do you have? See, it says that how much heat energy is released when 5 gram of water at 20 degrees Celsius changes to ice at 0 degrees Celsius, and then you have been given what? You have been given the values of specific heat capacity. How much heat energy is released? So what is the mass of water is equal to 5 gram. Okay, now what else has been given? Released when 5 gram of water changes to ice. So here you are going to take, so initially the water is just 20 degrees Celsius at water. So this first conversion will be, it is going to convert to water at 0 degrees Celsius, and then it is going to convert to ice at 0 degrees Celsius. So these are the two steps of energy conversions. Okay, so what you will be writing, for water at 20 degrees Celsius, to water at 0 degrees Celsius. See what you will be writing, energy. See here, energy will be released. Why released? Because the temperature is going down. This will be equal to mc into delta T. Now the question is, what is the value of C? It's given as 4.2 joule per gram per Kelvin. So here everything is in grams. So you can be writing down that this is equal to, what is the mass? Mass is 5 into 4.2 into delta T is what? 20 degree Celsius minus 0 degree. So this is 5 into 4.2 into 20. So which is equal to 4.2 into 100, which will be equal to 420 joules. Okay. Now here you can write, since C has been given to me as 4.2 joule per gram per Kelvin. Okay. So this is what you are going to write. And then what you will be writing for, maybe we can change the color. For water at 0 degrees Celsius to ice at 0 degrees Celsius, you'll write down the energy conversions. Okay, so energy conversion will be like this. See, energy released will be equal to what? Here it will be equal to m into L. Okay, because you are into specific latent heat. So mass again to me has been given as 5. Latent heat to me has been given as 336 joule per gram. So you can write it down that since L is equal to 336 joule per gram. Okay, so this you will be writing 336 into 5 is how much, children? 0, then 8, then 6, 1680 joule. So total amount of energy released, total amount of energy that is released is equal to 1680 joules plus 420 joules. So this is equal to how much? 0, 0, 0, 2100 joules. Okay, so this is your final answer, 2100 joules. Okay, so this way the second question has been done. We'll move on to the next question. What is the next question, children? The next question is, see, it says a molten metal of mass 150 gram is kept at its melting point. A molten metal of mass is kept at its melting point 800 degrees Celsius. Now what do you have to calculate? When it is allowed to freeze at the same temperature, it gives out 75,000 joule of heat energy. Now what you have to calculate is specific heat of latent heat of the metal, or if the specific heat capacity of the metal is this much, how much additional heat energy to cooling at minus 50 degree. Okay, so its melting point itself is 800 degrees Celsius, children. So here at the same temperature, what is the specific latent? So here what you are going to do, see, here you have melting point is 800 degrees Celsius. Okay, so what you have to, that's in molten form, and then you have to calculate that when it freezes at 800, obviously it's freezing at the same temperature, then what is the specific latent heat of the metal? Okay, so here what is the mass of metal? Mass of metal to me has been given as 150 grams. Okay, then what is the amount of heat released? It is equal to 75,000 joules. Then what is the formula? See, latent heat specific latent heat, L will be equal to what is? It is given by Q divided by M. Why? Because children, since Q is equal to M into L. So here, what is happening? Temperature change is not happening, only phase change is happening. So here we will be using the term specific latent heat. So how much will this be equal to? 75,000 divided by 150. So this is going to be equal to 500 joule per gram. Okay, so this is for your first sub question, that is A. Now for the second sub question, what is happening? If the specific heat capacity of the metal is, so write down what is the specific heat capacity. Capacity is equal to C, which is equal to how much? 200 joule per kg. Per kg per Kelvin. How much additional heat will the metal give out in cooling to minus 50 degrees Celsius? Okay, children. So what will be delta T here? Delta T is the initial temperature, final temperature, or whatever. See, it has to be positive. Nevertheless, what is the final or initial? So from 800 degree, you are changing it to minus 50. So this is equal to 800 plus degrees Celsius. Okay, plus 50 degrees Celsius. So this is 850 degrees Celsius. And of course, you have the mass with you as 150. Okay, so this is an easy one. So how much metal give out? So what you will be writing? Amount of energy released Why is it releasing? Because the temperature is going down. So when the temperature goes down, the energy is always released. So what is the mass? Mass here you have 150. What is C? C to me has been given as, okay children, so here you need to see that the specific heat capacity has been given in, if you can see, it's kg. So we need to convert this into grams, sorry, kg. So this is 0.15 kg. So instead of this, write down 0.15 into 200 into 850. So this is actually equal to how much? 0.15 into 2 is 0.3330. 30 into 850. Okay, so this is 15 5s are 3 5s are 15, 8 3s are 24, 2 5 and 2 zeros. So this is the amount of energy released. 2000, 25,500. Okay, which matches with the answer. So this is the way the third question has to be done. We'll move on to the fourth question, children. Okay, so what is the fourth question? Fourth question says a solid metal of mass 150 gram melts at its melting point of 800 degrees Celsius by providing, okay, very much similar to the one that we have done. Okay, so here you at the rate of 100 watt. What is the time? The time taken for it to completely melt is 4 minutes. Now you have to calculate the specific latent heat. So this question was asked in one of the previous years. So this is important. So, but then this is an easy one. So what is happening? The same mass has been given. So write down mass is equal to how much? Mass is equal to 150 grams. Okay. Now melting point is how much? Melts at its melting point 800 by providing a heat at the rate of, so they have given power here. What is the power? Power to me has been given as 100 watt. Okay. Now, what is the time? Time to us has been given as 4 minutes. Okay. So obviously it has to be converted into seconds. So this we will be writing as 240 seconds. Okay, so what do you have to calculate here? That what is the specific latent heat of fusion? So what we will be writing, let the specific latent heat of fusion be heat of fusion be L. Okay, then obviously what you will be writing then? Here you will be writing therefore amount of heat released will be how much, children? This is equal to M into L. Okay, so M into L. So what is the mass? Mass has been given as 150, and then this needs to be converted into standard unit, children. Since watt is a standard unit, so you will be converting this into kg. Okay, so this will be writing as 0.15 into L. Okay, now what you will be calculating is the power. Okay, so what is the formula of power, children? Power is equal to Q divided by T. Okay, so if we have to replace the value, power to me has been given as C. This implies Q will be equal to power into time. So this implies just replace the values. 0.15 into L is equal to power is 100 into time is 240. So this further implies that L will be equal to 100 into 240 divided by 0.15. Okay, now you need to calculate this. So we can just remove the decimals by doing like this. 240 into C. This, if it is taken as 15 here, you can send 100 here. And then we can calculate. So this divided by 5 will be 20 and this will be 3. So here it gets cancelled, 80. So you are getting 8 2s are 16. 1, 2, 3, 4. And what will be the unit? The unit here has to be joule. So this in turn, no, it's latent heat, so joule per kg. So if we are going to write this in the power notation, this will be 1.6 into 10 raised to 5 joule per kg. Okay, so this is the answer that you're getting for question number 4. So it was also an easy one. You just have to take care of the units which are there. Now moving on to the next question, that is question number 5. So in question number 5, the question goes like this. A refrigerator converts 100 gram of water at 20 degree to ice at -10 in this much time. Calculate the average rate of heat extraction in watt. So you have to calculate the average rate of heat. So what is this average rate of heat extraction? It's actually power that you need to calculate. Okay. In watt, the specific heat capacity and all has been given. So what is happening? See, the water initially it is at 20 degrees Celsius. So it needs to be converted to water at 0 degrees Celsius, and then it needs to be converted to ice at 0 degrees Celsius, and then it needs to be converted to ice at -10 degrees Celsius. So you have 3 stages here, children. Okay, so you need to calculate for all of them. So we'll just see how it goes. See, so what you will be writing, we'll be writing like this. For water at 20 degrees Celsius to water at 0 degrees Celsius. What is the mass? First of all, mass to us has been given as 100 grams. And then what is the specific heat capacity? C to us has been given as 4.2 joule per gram per Kelvin. And what is the delta T here? Delta T here will be 20. Okay, so what will be the amount of energy release? We'll write down this as E1. This will be equal to energy released, or you can write down even here. Okay, will be equal to mc into delta t. So this will be equal to 100 into 4.2 into 20. So how much is this equal to? 420 into 20, which will be equal to 840, no, one more zero, 8,400 joules. Okay, so this has been done. And next you will be moving to for water at 0 degree. So this is your step 1. If you want, you can write it down. If you don't want, it's fine. And then this is your step 2. To water at, sorry, ice at 0 degrees Celsius. Okay. So here also the latent heat to us has been given as specific latent heat is 336 joule per gram. Okay. So what will be energy released? Will be equal to this. We are going to take as E2. This is equal to how much? Mass, that is equal to 100 into 336. Okay. So how much will this be equal to? 33,600 joule. Okay. And then we'll go to the third step, that is for ice at 0 degrees Celsius to ice at minus 10 degrees Celsius. What will be, what they have given? Specific heat capacity of ice. So write down the small c here is equal to 2.1 joule per gram per Kelvin. Okay. And what is the temperature difference that has been given? Delta T is equal to minus 10, right? So this will be equal to 10. So what is the energy released? This is equal to mc delta T again. So this here will be equal to 100 into C is 2.1 into 10. So this is 21 into 100, that is 2100 joule. And this we are going to take as E3. Okay. So what next you are going to write is total amount of energy released. Amount of energy that is released will be equal to E1 plus E2 plus E3. So this in turn will be equal to 8400 plus 33600 joule plus 2100 joule. So how much is this total equal to? This total is equal to 0, 0. Then you have 4 plus 6 and 1. And then you have 2, 3 is 5. 5 plus 8 is 13. 1 carryover is 4. And then 3. So 44,100 joule. Okay. Then what is the time taken? Because you need to calculate the power. This to me has been given as 73.5 minutes. So you need to calculate this in seconds, children. So this will be equal to 73.5 into 60 seconds. So how much will this be equal to? 6 3s 6 5s are 30, 0 3 carry over 1. And then 6 7 is a 42, 4 4 this seconds. Okay. So what is the power? The formula of power is energy divided by time. So what is the energy that we have calculated? 44100. Okay, so we are getting good numbers which will be cancelled. So here joule, here seconds. So what is that we are getting is joule per second, or this is also called 10 watt. Okay, so you are getting 10 watt as the answer. So this is your question number 5. Now moving on to question number 6, children. So question number 6 is what? It says, in an experiment, 17 gram of ice is used to bring down the temperature of 40 gram of water at 34 degrees Celsius to its freezing temperature. Now you have to calculate the specific latent heat of ice, and you have to state one important assumption that you have taken while calculating this particular numerical. Okay, 17 gram of ice is used to bring down the temperature of 40 gram of water. Okay, so here there are two things that are involved. So here one we have ice, and on the side we have water. Okay, so for ice they are saying the mass is 17 gram. Okay, temperature to 34 degrees to its weight is used to bring down the temperature of 40 gram of water at 34 degrees Celsius. Okay, so the water, what is the temperature for water? The temperature for water is here 34 degrees Celsius. To its freezing temperature means it is coming to 0 degrees Celsius. Okay, so you have to calculate the specific latent heat. So you don't have to write these things. I'll just explain you how to do. This is just for making you understand. So we'll start with for ice maybe. Okay, for ice, the mass of ice is equal to 17 grams. Okay, latent heat, specific latent heat of fusion BL. Okay, so this, because that is what you have to calculate, so you can write down here, let the specific heat be of fusion be L. So subsequently, what will be the amount of energy released? This will be equal to M into L, which is equal to 17 into L. Okay, this is joule. Now we'll be calculating for water. Mass of water to us has been given as how much? 40 gram. Okay, and then you know what is the specific heat capacity of water. They have already given you is 4.2 joule per gram per Kelvin. And then what is the delta T? Then it is coming to its freezing temperature. So here it's like 34 degrees to 0 degrees. So the delta T here is 34. Okay, so what will you be writing? Amount of energy released will be equal to MC into delta T. So here this is 40 into 4.2 into 34. Okay, I'll just use the calculator. 44, 30, 30, 40, 34 into 4.2 into 40. Okay, so this has been calculated as 5712 joule. Before that, here we need to make a correction. When the ice is melting, the energy will be absorbed, not released. Okay, so what you will be writing? Heat energy absorbed by ice is equal to heat energy released by water. Okay. So this implies 17 into L is equal to 5712. Or else for the ease of our calculation, we could have left it like this. I'll just show you children what is the easy way to do. See, you could have left it like this, 40 into 4.2 into 34. So L would have been equal to 40 into 4.2 into 34 divided by 17. Now that you are grown up kids, you should know that how to ease your calculations. So here you are getting 80 into 4.2. So this is 6, 8 fours are 32, and then you have one carryover, so 336 joule per gram. So we could have saved ourselves from the calculations. And then the question is, what is the assumption made? Then the assumption that you are making is that there is no loss of energy. Okay, had there been a loss of energy, we could not have calculated this. So we are assuming that no energy is dissipated in any other form. Okay, so this was also an easy one. We'll move to question number 7. Okay, so what is question number 7? It says the temperature of 170 gram of water at 50 degrees Celsius lowered to 5 degrees Celsius by adding a certain amount of ice. Find the amount of ice that has been added. So what they are saying here, the temperature of 170 gram of water. So here also you have two terms, you have water and then you have ice, and then you are mixing both of them. Okay, so we will be calculating. So write down like this. For first we'll be starting with water maybe. Okay. For water, write down mass. You can take this as M1 is equal to 170 gram. Okay. And then you can take what is the specific heat capacity. They have given 4200 joule per kg per Celsius. So per kg means even this has to be calculated in kg. Okay. What is the temperature change? Lower to 5 degrees Celsius, children. Okay. So 5 degrees Celsius means delta T is how much? 50 degrees minus 5 degrees Celsius. So this to me is coming out to be 55 degrees Celsius. So what is the amount of energy released? This will be equal to C. M1C into delta T. So this is 0.17 into C is 4200 into 45. Okay, so this needs to be calculated. We will just calculate it with the help of calculator. So 4200 into this much into this. We'll just calculate. Wait. 4200 into 0.17 into 45. So this is 32,130. So this is joule. Okay. And then by adding a certain amount of ice. Okay. Now what you will be writing? We'll be writing for ice. Let the amount of ice added be X grams. Okay. So see, two things are happening, children. First, the ice, it has 0 degrees Celsius. It's coming to water at 0 degrees Celsius. Okay. Then this is converting to water at 5 degrees Celsius. Okay. So these are the energy conversions that you have to use. So what you will be writing, amount of energy released by how much gram, children? With a x gram of water to convert from 0 degrees Celsius to water at 0 degrees Celsius. So this will be ice is equal to M into L. So what is L, children? L to us has been given as heat of ice is 3600. So write down M into 336,000 joules. Okay, and then the same thing, children, amount of energy released by x gram of ice to convert from 0 degree from from here you can be writing x gram of ice to convert from water at 0 degree to water at 5 degrees is equal to M into C into delta T. So this in turn will be equal to, you have taken this as M. Okay, so you can take the, instead of mx, children, take this as M so that this will be easy. So this will be equal to M. C is of course 4200 again, and delta T is 5. So how much is this equal to? This is equal to 1,000 joules. Okay, so this is what you are getting. M into, and of course you have M into 21,000. Okay, so what you will be writing? You will be writing down here. What you can do for your ease, you can be taking this one as E1, this one as E2, and this one as E3. Okay, then what you will be writing? Amount of energy released by water at 50 degrees Celsius to 5 degrees Celsius is equal to amount of energy absorbed by ice from 0 degrees Celsius to water at 5 degrees Celsius. This implies E1 will be equal to E2 plus E3, which further implies that 32130 will be equal to 33600 M plus 21,000 M. So this implies how much will this be equal to, children? 21,000 is 4,205. 30 56 and 21 will be a what amount? So is there any place that we have done some? Okay, so here you have 3 zeros, children, sorry. So this is 32130 is equal to 35700 m. So m will be equal to 32130 divided by 35700 grams. So we'll calculate this. So this is going to be coming out as, wait, we'll just calculate, children, divided by 357,000. So this is equal to 0.09 grams. Kg, sorry, not grams. Why? Because everything here was in kg. So this you can be writing as 90 grams. Okay, so this is the way this has to be done. So this comes out to be equal to 90 grams. So the question was easy. It's just that how you are writing it down that is making this lengthier. The concept is an easy one. Okay. We'll move on to the next one. That is question number 8. So for question number 8, the question is, find the result of mixing 10 gram of ice at -10 degrees Celsius with 10 gram of water at 10 degrees Celsius. And then you have been giving the specific heat capacity of ice is this much. So what they are saying that there is 10 gram of ice. Okay, so ice is at 10 gram and it is at -10 degrees Celsius, and you're mixing it with water that is also 10 gram and that is at 10 degrees Celsius. Okay, and then what is the result of mixing? So we will just assume that they are coming to a temperature T that is intermediate between the -10 and 10 degrees. Okay, so what you will be writing, let the final temperature of the mixture be mixture B. Maybe you can take capital T. Okay, so what is the thing that we will be calculating? First, ice is -10 degree. 2, we will calculate to ice at 0 degrees Celsius, and then we will calculate to water at 0 degrees Celsius. Okay, and then we will calculate this up to water at T degrees Celsius. Okay. So these are the 3 steps that you will be taking. And then after that, what we'll be doing? Okay, first will be, and for this water, which is already at 10 degrees Celsius, we will just calculate it up to when it comes to water at T degrees Celsius. So that will be small one. Okay, so we'll just write it in a proper way. So write down like this: for ice at -10 degrees to ice at 0 degrees. So what will be the amount of energy released? E1 will be equal to, write down mc delta T. So this will be equal to, m to us has been given as 10 into specific heat capacity of ice is 2.1. Okay, and the temperature change is 10. So this is equal to 210 joules. Okay, we'll go down to the next one. Okay, so next one is for ice at 0 degrees Celsius to ice at, water at 0 degrees Celsius. What is E2 equal to? E2 will be equal to M into L, because only the phase is changing. Okay, so the M to us has been given at 10, and if you see what is the specific latent heat of ice, it has been given as 336. So this is equal to 3360 joule. Okay, so this is now what you will be writing for water at 0 degrees to water at T degrees, because that is what you are taking, that it is going up to T degrees. Okay, energy, this will be equal to again MC delta T. So M is 10, specific heat capacity of water is how much? 4.2 into T. So this is 42 T. Okay, so this is for ice. Now what you will be writing for water at 10 degrees Celsius to water at T degrees Celsius. Okay, because that is also getting decreased, right? We are talking about this water now. This water, which was at 10 degrees Celsius, now it also has to come out to T degrees Celsius, because that is the intermediate temperature. So all these steps which were there, this were for this conversion. Now this particular step is for this conversion. Okay, so what you will be writing, energy released will be equal to if maybe you can write this as E4 is equal to how much? MC delta T again. So M to us has been given as T into C is how much? 4.2 into 10 minus T. Why? Because that's the final temperature. So here how much you are getting this? 42 into 10 minus T. So more often you can write it as 420 minus 42 T. Okay, now what you will be writing, energy absorbed ice at minus 10 degrees Celsius to water at 3 degrees Celsius will be equal to energy released by water at 10 degrees to water at 10 degrees. So you can also write this as, this implies E1 plus E2 plus E3 will be equal to E4. So we'll just calculate. This implies 210, write down, plus 3360 plus 442T will be equal to 420 minus 42T. Okay, we'll just calculate this. So this is coming out to be, we'll use calci again. Wait, 210 plus 3360 minus 420, 3150 minus 84T. So you are coming, this is going to be equal to, this implies T is equal to 3150 divided by minus 84, which we are calculating as minus 37.5 degrees Celsius. So you can see that we had assumed that the final temperature be 3 degrees Celsius, but it is coming as minus 37.5. So we clearly know that water cannot exist at this temperature. Okay, what does this mean? It clearly means that our assumption is wrong. Okay, so this implies that the whole ice has not melted. Okay, so what is the amount of ice that got melted? That needs to be calculated. So first you need to show us this much, and then only you can conclude that okay, that whole amount of ice is not melting, so there is some amount. Okay, so what you will be writing, let X gram of ice melts. Okay. So what you will be writing, amount of heat energy, you can write in line here. Our ice at minus 10 degrees Celsius to ice at 0 degrees Celsius. What will be the energy change? It will be equal to again m into c into delta T. So this will be equal to 10 into 2.1 into delta T is 10. So this is again equal to 210 joule. Okay. Now what you will be writing, that amount of energy absorbed by, see, the entire amount is melting first that you are getting, but then we will say that what is m gram is, or x gram that you have taken is taking, okay, of ice at 0 degree to convert into water at 0 degrees. Okay, why? Because we are assuming that only some of the ice has been melted. So this will be equal to m into L. So m you have taken as x into 336. So this is 336x joule. Okay. Now you have to also calculate the another side for water at 10 degrees to water at 0 degree. See what will be the energy conversion. Let this be E1, then let this be E2. So E3 will be equal to again m into c into delta T. So this will be equal to 10 into 4.2 into delta T is how much? 10 minus 0. So this is equal to 42 into 10, which is equal to 420 joules. Okay. So now what you will be writing, heat energy absorbed by ice will be equal to heat energy released by water. So this implies what you will be writing, 210 plus 336x is equal to 420. So this implies 336x is equal to 420 minus 210, which is equal to 210. So this implies x, that is the amount of ice that has melted, okay, is equal to this much, 336. If we divide this, divided by 3 is 70 divided by 112. Okay, so this is equal to 7 goes 10 divided by 7 is how much? 1 and 6. So this is 5 divided by 8, which will be equal to how much? 0.6. Then 20 is 5 grams. So this much is the amount of ice that has melted. Okay, so this was a long question that can be asked. So wherein first you will be assuming that the entire amount of ice is melted, and then you will assume that once you conclude that the temperature is coming out in negative, then you will come to a conclusion that only some amount of ice has melted, and then accordingly you can see. Okay, so this is the way this has to be done. This was a lengthy one. Now moving on to question number 9, children. So what is question number 9? It says, okay, we are in question number Yeah, 9. A piece of ice of mass 40 gram is added to 200 of water at 5. Calculate the final temperature of the water. So this is going to be an easy one. Okay. So a piece of ice, yes. See, so here what is happening? You have ice, which is of 40 grams. It is added to 200 grams of water. Okay, the water is 200 grams and it is at the temperature 50 degrees Celsius. So you have to calculate what is the final temperature when the ice has melted. Okay, so for that, what you have to calculate that first of all, you have to take it to a final temperature. Okay, so what is happening for ice, you will be calculating first. So we will be taking a normal temperature. Like normal temperature means we will be taking a final temperature. So what we'll be taking, let the final temperature of the mixture be T degrees Celsius. Okay, and then what we'll be calculating, see here, I'll just write down in draft. The ice will be at a 0 degree will be converted to water at 0 degree, and this will be converted to water at T degrees Celsius. So you need to write down. Then again you have water at 50 degrees Celsius. This is for second scale, and this will be converted to water at T degrees Celsius, and then you will equate both of them. Okay, so what you are going to write, first of all, we will be writing for ice. Okay, so write down for ice at 0 degrees Celsius to water at 0 degrees Celsius. First of all, write down M1. This you will be taking as E1. Okay, E1 we'll write down afterwards. Write down M is equal to how much? 40 grams. And what is the latent heat of fusion? So this is equal to specific latent heat of fusion of ice they have given us. Okay, again they have used kg here, joule per kg. So obviously you need to convert it. So either you are converting both of them to kg or you are converting both of them to grams. So if you can see what we can be doing, children, for the ease of calculations, let us see what else has been given. Okay, what we can be doing, we can be just converting this into grams. I think that will be easy one. So this will be 200 and 336 joule per gram. So what will be E1? That will be equal to M into L, that is 40 into 336 joules. Okay, so this is how much? 6 of 4, and then you have 1 again 4, and then you have 13. So 1300 and then 1 zeros. So this is joule. Okay, and then write down for water at 0 degree to water at T degrees Celsius. Okay, what will be energy conversion? This will be equal to mc into delta T. So mass has been given as 10. Then what is this 4200 joule per kg per Kelvin? Okay, so how much will be that equal to? 4.2 joule per gram, children. Okay, because now you are taking everything in gram. Into delta T will be how much? T minus 0. Okay, so this is 42 into T minus 0. So this will be how much? 10 into 42. Okay, So this is, okay, we have taken M amount of N vacuum. Okay, so this is 40 children. I'm sorry. We'll just erase it off. So this is 168, 42 into 40. So you are getting 168 T. Okay, so ice has been done, and now we will be doing for water. Okay, so write down for water at 50 degrees Celsius to water at T degrees Celsius. What is the energy conversion? So mass to us has been given as 200 grams. C is equal to 4200 joule per kg per Kelvin. So this can be written as 4.2 joule per gram per Kelvin. And delta T is equal to 50 minus T. So Q here, or energy, you can be writing as E3 will be equal to MC delta T. So this will be equal to 200 into 4.2 into 50 minus T. Okay, so 4.2 into 2 is 8.4. So this is 840 into 50 minus T. Okay, so 15,000, 1,000, So this is coming out to be 42000 minus 840 T. Okay, so this is what you are getting, and now we will just write down. Okay, so write down here amount of energy released by ice is equal to amount of energy gained by water. Gained by water. Okay, so what will this imply? This will simply imply that E1 plus E2 is equal to E3. So this implies 13440 168 T is equal to 42,000 minus 840 T. Okay, so what will this imply? This will simply imply that 42,000 minus 13440 is equal to 840 T plus 168 T. So how much will this be equal to? If you subtract, this is equal to 0, 6, 5, 8, 2 is equal to, upon addition, this is going to be equal to 8001. So this is equal, this implies T is equal to 28560 divided by 1008. We'll just calculate 28560 divided by 1008. So this is equal to 28.33 degrees Celsius. Okay, so this is what we are getting, 28.33 degrees Celsius. So this is your question number 9. Was an easy one, but then the writing part is a lengthy one. Okay, we'll move on to question number 10. So question number 10 is what? Calculate the mass of ice needed to cool 150 gram of water contained in calorimeter, okay, of mass 50 grams, such that the, okay, so there is this calorimeter, okay, and in that you have water which is at how much degrees? 32 degrees. Okay, now you need to add ice to it so that the final temperature comes down to 5 degrees Celsius. So what is the mass of ice that is needed? So this is your question. Now here you have to see that in addition to your water, you have calorimeter as well. So both the things you need to take into account. So the calorimeter and also the water that is inside it. Okay, so what you are going to do, see, let the amount of ice needed be, write down, let the amount, mass of ice, you can write, mass of ice needed to cool be m grams. Okay, then what you will be writing, you will be writing like this: for water at 32 degrees Celsius, okay, to water at 5 degrees Celsius. We'll be calculating this. Okay, write down what is the mass. First of all, write down those things. So the mass to us has been given as what is the mass of water contained calorimeter of 150 grams. Okay, so write down 150 grams. You know what is C? It's 404.2 joule per gram per Celsius. Okay, and delta T will be how much? Delta T is going to 32 degrees Celsius minus 5 degrees Celsius. So this is 27 degrees Celsius. So what is the energy? E1 will be equal to mc delta T. So this is 150 27. Okay, so this is what you are getting. 150 into 4.2 into 27. So I don't think there is a point in leaving it like this. So we'll calculate. This is 150 into 4.2. Wait. 150 into 4.2 into 27. So this is 17010 joule. Okay. Next, what you will be writing for calorimeter, at calorimeter is also at the same degrees, children. It is also at 32 degrees Celsius to 5 degrees Celsius. What you will be writing, the mass is how much they have given, 50 grams, children. Okay, C to us has been given as 0. So what is the hint that you need to proceed in this way is that the specific heat capacity of calorimeter has been given. So everything else here is same except the fact that you have to use for calorimeter also. Okay, so what is delta T? Delta T is here is again 27 degrees Celsius. So energy E2, what is the energy released, will be equal to mc delta T. Okay, you can take this as mass, maybe m1 because we are using all the time mm. Okay, so this is 50 0.4 into 27. Okay, how much will this be? Equal to 50 into 0.4 is equal to 5 was a 20. So it's 20. Okay, into 27. So we are getting 540 joules. Okay, so this is the total. And then we will come to ice. Okay, so what is, calculate the mass of ice required to cool this much. Okay, so what we will be heat by ice. So what you will be writing, for ice at 0 degrees Celsius to ice at, water at 0 degrees. What is the M? M will be M1. M is equal to M1, and latent heat has been given as how much? Capacity of ice is 330 joule per gram. Okay, so what you will be writing, energy released E3 will be equal to M1 into 330 L, not L, sorry, joule. So this is 330 M1J. Okay, and then what you will be writing, this is the fourth one, that for water at 0 degrees Celsius to water at 5 degrees Celsius. What is the energy conversion, children? E will be equal to E4 will be equal to MC delta T. So M you have taken as M1, C is how much? 4.2 and delta T is 5. So how much will this be? Equal to 4.2 into 5 is 21. So you're getting 21 M1. Okay, so you're done with all the individual solving part, and now you'll just add them up. Now what you will be writing? Energy released by water plus calorimeter is equal to energy gained by rise by ice. Okay, so this implies E1 plus E2 is equal to E3 plus E4. Okay, so how much is this? 17010 plus 540 is equal to 330 M1 plus 21 M1. Okay, so we'll just add this up. So how much we are getting? Plus 540. 17550 is equal to 351 M1. This is M1, children. So this implies M1 is equal to 17550 divided by 351, which is equal to into 5 into 5. So this is going to be 50 grams. So this is the answer that you are getting. This is also very much similar to the other questions, just a change that you need to consider the mass and specific heat of calorimeter as well. Okay, so this is the way this has to be done. So we are done to question number 10. We'll move on to question number 11. Okay, so this is question number 11. So in question number 11, it says 250 gram of water as 30 degrees is contained in a copper vessel of mass this much. Calculate the mass of ice required to bring down the temperature of vessel to this much. Okay, so this question is also very much similar. So what you will be writing, that let the amount of ice required be M. Okay, let the amount of ice required be M. So what is happening here, children? So here you have again a copper vessel, and then you have water here. So you need to, from 30 degrees, they're at 30 degrees, and you need to bring down to 5 degrees Celsius. Okay, so what you will be writing, write down like this: for water at 30 degrees Celsius to water at 5 degrees Celsius, See, mass has been given as 250 grams. Okay. And what is the specific heat capacity? They have given here in kg. So it's always preferable if you convert that into grams, so that it will be easy for calculation. So C to us has been given as 4200. Okay. Joule per kg per Kelvin. So this is equal to 4.2. Excuse me. And then we have delta T. So delta T will be equal to how much? 30 degrees Celsius minus 5 degrees Celsius, which is 25 degrees Celsius. Okay. So energy conversion here, E1 will be equal to MC into delta T. So this is 250 into 4.2. Okay. Into 25. So how much is this equal to? We'll just calculate. 250 into 25 is 625 into 4.2. So we'll be writing here this as 6250 into 4.2. 6250 into 4.2. So this is 26250 joule. All right. And then what we'll be writing for calorie, not calorimeter here, for copper at 30 degrees Celsius to copper at 5 degrees Celsius. The mass has been given as how much, children? See, what is the mass contained in 50 grams? Okay. So write down M is equal to 50 grams. C is equal to, for copper, it has been given as 400, children. Joule per kg per Kelvin. So this you will be writing as 0.4, because you have to bring it to -3. So this will be joule per gram per Kelvin, and delta T here also is 25 degrees Celsius. So what will be E2 equal to? E2 will be equal to MC into delta T. So this will be 50 into 0.4 into 25. Okay. So how much is this equal to? 25 into 0.4 will be 1. So this is going to be 25 into 0.4 is 10. Okay, sorry. So this is 500 joule. Okay, and now we'll move to ice. Okay, for ice at 0 degree to water at 0 degrees Celsius, mass is equal to, we have taken as, we'll take as M1 again, children, not just M1, and latent heat will be equal to how much? 336 joule per gram per Kelvin. In the question, you have been given in terms of kg. You can easily convert that in grams. So E3 will be equal to how much? M1 into L. So this is 336 M1. And now it will be good if I just underline this. Yes, so that you can, differentiate between all. So write down for water at 0 degree to water at 5 degrees Celsius. See, what will happen? M is equal to M1. C, is 4.2 joule per gram per Kelvin, and delta T is equal to 5. So E4 here will be equal to MC delta T, which is equal to M1 into 4.2 into 5. So this is 21 M1. Okay. So this is what you're getting. And now we'll just solve it up. Just underline this one as well. We'll just erase off the right hand side. Put a line over here. Write down energy released by water plus vessel is equal to energy gained by ice. Gained by ice. So this implies what? E1 plus E2 is equal to E3 plus E4. Okay, so write down 26250 plus 500 is equal to 336 M1 plus 21 M1. So this implies 26750 is equal to 357 M1. So this implies M1 will be equal to 26750 divided by 357. We'll just calculate this. So this is coming out to be equal to 26750 divided by 357. 74.92. 9. Sorry. Which is equal to 74.93 grams. Okay, so this is the answer that you are getting, very much similar to the previous sum. Okay, it's just that in place of calorimeter, we had copper vessel. Okay, now moving on to the next question, that is question number 12. So this is your question number 12. It says 2 kg of ice melts when water at 100 degrees is poured on a hole drilled on the ice. What is the mass of water used? Okay, so what are they saying? 2 kg of ice is melting. Okay, so it means at when water at 100 degrees. So here you have ice, so it will convert to what is ice at 0 degree. It is converting to water at 0 degrees. Okay, and here the mass is 2 kg. Okay, then here you have water at 100 degrees Celsius, and this is being poured, and this is being brought to water at 0 degrees Celsius. Okay, now you have to calculate that how much mass is there. Okay, so how are we going to do this? Okay, initial temperature. We'll start with this. Let the amount of water poured used or poured, whatever, is equal to mkg. Okay, so it is reducing. So write down amount of energy lost by water, mkg you can write, of water (100°C) to reduce to water at 0°C is equal to mc into delta T. So this is equal to m is m into what is c is 4.2. Okay, but then here since everything is in kg, so we'll be taking as 4200 joule per kg into delta T is again 100. So this is 420000 4 zeros. Okay, M joule. Now what you will be writing for ice at 0 degrees Celsius to water at 0 degrees Celsius, mass will be equal to 2 kg. This is what has been given. And latent, since the phase is not changing, so we will be taking the latent heat. So the latent heat has been given as 336 joule per gram, children, which again needs to be converted. Okay, so this is 336 joule per gram, which is equal to 336000 joule per kg. So write down what is energy. M into L, which is 2 into 336000. So this will be equal to 672 joules. Okay. Now what you will be writing? The heat energy released by water at 100 degrees is equal to heat energy absorbed by ice at 0 degrees Celsius. So this implies what? 42000 4 zeros M is equal to 672123. So M will be equal to 672 000 42123. So we'll just calculate this. So this is 672123 divided by 421234. So you are getting 1.6. So this is 1.6 kg. An easy sum. Just the simple energy conversion. So you are getting here 1.6 kg. Okay. Now moving on to question number 13. So question number 13 is what? Calculate the total amount of heat energy required to convert 100 gram of ice at minus 10 degrees Celsius completely to water at 100 degrees Celsius. Okay, so this is again going to be an easy one, children. So what you are going to do, amount of energy required to convert 100 gram of, so ice is at minus 10 degrees Celsius, then you have to bring it to ice at 0 degrees Celsius, then you have to bring it at water at 0 degrees Celsius. So you have then water at 100 degrees Celsius. Okay, so what you will be writing for ice at minus 10 degrees Celsius to ice at 0 degrees Celsius. Okay, what is M? Mass is 100 grams. Okay, then what is C? C here is equal to, everything is in grams, specific heat of ice is 2.1 joule per gram per Kelvin, and delta T is equal to 10 degrees Celsius. So what will be E1 equal to? E1 will be equal to MC delta T. So this is 100 into 2.1 into 10. So this is equal to 2100 joules. Okay, and then what we will be writing for ice at 0 degrees Celsius to water at 0 degrees Celsius. Mass again is equal to 100 grams. Okay. Then since the phase is changing and without the change in temperature, we'll be taking into account the latent heat, joule per gram per Kelvin. So Q here or E will be equal to M into L, which is 100 into 4.2, which is 420 joules. Okay. So now next. So this is per gram. Okay, sorry. This is 336 children. Latent heat is 336. 336. We'll just erase it off. So this is 33600 joules. Okay. Now we'll be writing for water at 0 degrees Celsius to water at 100 degrees Celsius. The mass again will be equal to 100 grams. Now here C will be equal to 4.2 joule. Okay, then again here, this is joule per gram only. Joule per gram per Kelvin. And delta T here is 100. Okay, so what is E3 equal to? 100 into 4.2 into 100. This is going to be a big number. 420 and 2 zeros, so 42,000 joules. So what you will be writing? Total energy that is absorbed will be equal to E1 plus E2 plus E3. So this is equal to 2100 plus 33600 plus 42,000. So when you add them up, you are getting 0, 0, here 7, 7 and 7. Okay. So this is joule. So if you want to write this as in the power notation form, so 7.77 into 10 raised to 4 joules. Or you can be writing 77.7 kilojoule. Okay. So this is the way this has to be done. Was an easy one. Moving on to question number 14. So this is your question number 14. The amount of heat energy required to convert 1 kg of ice at -10 to water at is this much. Calculate the specific latent heat of ice. So this question is very much similar to question number 13, children. So here what you are going to do. See, here what you will be writing, I'll just give you hint and you can be taking as homework. So here you have required to convert. So here you have ice at 0 -10 degrees Celsius. So this will be getting converted to ice at 0 degrees Celsius. Then this will be getting converted to water at 0 degrees Celsius and water at 100 degrees Celsius. Okay. So in this process here, it will be E1, the first energy. This is E2 and this is E3, and the sum of all the three of them to you has been given as 777,000. So E1 will be how much? MC delta T. So M is 100 into specific heat. You have been given as 2.1 into delta T is 10 here. Okay, and here you have masses again. E2 is M into L. So M is 100 and L is what you need to calculate. So this is plus. And then you have E3 as again MC delta T. So here mass is 100. C is 4.2 into delta T is 100. So you are going to add all these three and this will be equal to 7. Okay? So you can easily calculate the answer. So this one being an easy one, you will be taking this as homework. Okay, we'll be moving to the last question. That is question number 15. So question number 15 is 200 gram of ice at 0 degree converts into water at 0 degree in 1 minute. Okay, when heat is supplied at the constant rate. So this is a word, children, that you have to take into account, that the heat is being applied at the constant rate. Okay, so write down what you'll be writing down here. 200 gram of ice. So here you have ice at 0 degrees Celsius, which is being converted to water at 0 degrees Celsius. So what you will be writing, mass of ice is equal to 200 grams. Okay, and then what you will be writing, specific latent heat of fusion, specific latent heat of ice. Okay, what the specific latent heat of ice is for? Write down latent heat of ice, that is equal to L is equal to, sorry, 120 joule per gram. Okay, so what you will be writing, heat energy absorbed M into L, which is equal to 200 into 336 joules. So if you calculate this, you will be getting 672.00 joules. So what is this? This is the amount of energy that is being released. Okay, and now how much is this in 1 minute? Okay, write down time required is equal to 1 minute. And then what you will be writing, rate of heat exchange will be equal to what? Heat absorbed divided by time. Okay, because you are calculating it. So this is 67200 and is equal to, you can write down here 60 seconds divided by 60. So how much will this be equal to? Oh, just calculate. 67200 divided by 60, 1120. This is joule per second. Okay, so now this is what you're getting. Now they are asking 0 degree to 20 degrees. So write down, for water at 0 degrees Celsius to 20 degrees Celsius, M is equal to how much? 200 grams. Okay, delta T is equal to 20 and C is how much? This is 4.2. By now, you must have remembered the value. Okay, so they are asking you time. So write down energy released. Here also the energy is being absorbed, not released. So this is 200 into 20 into 4.2. So how much is this equal to? 4.2 is 84. 84 into 2 is, we just calculate, into 20 into 4.2. 16800. Okay, so this is joules. Okay, and then what you will be writing, let the time required be t seconds. Okay, then what you will be writing, since the rate of heat exchange is constant, therefore one 1120 that you are getting from here will be equal to 16800 divided by T. Okay, the rate of heat exchange here. So this implies T will be equal to 16800 divided by 1120. So we'll just calculate this. This is coming out to be 50 seconds. Okay, so this is the answer. If you want, you can add up one line here and give this star mark. Okay, so what you will be writing, the rate of heat exchange is equal to energy divided by time. Okay, so this is 16800 divided by T. Okay, if you want, you can take this as, so basically here, if it is constant, so this is equal to this, and then you can calculate the answer. Okay, so we are done with the exercise. I hope you all understood the question. Any doubts, you can be further asking. All right, thank you, students.